Hello everyone. Today we are going to learn about building a machine learning algorithm to detect fake news. It's part of a mini project. For that, we first need to know a few of the prerequisites that some terms and methods to build the algorithm. First, tokenization. Tokenization is actually converting a huge paragraph into tokens or into sentences or into words. So see, here is a really big paragraph that we have in our hands, and we can convert it into a list of sentences or into list of words. All right. So after this, the second concept is cleaning the text. Say we want to only work upon a particular uh, paragraph and we would like to remove all the punctuation marks that it has. All right. So you can see there are lots and lots of punctuations in it. So by removing that, we'll get to know the letters or the words in this particular sentence. All right. So the third is stop words. Stop words are actually the conjunctions or the pronouns that we often use in a particular language. So for English language, stop words are I, me, myself, we, are, ours, ourselves, etc. So these need not be taken into account while building up the machine learning algorithm because they are, they appear in a sentence quite often and might steal the, feature or the weightage that we will further calculate. All right. So for an example, here we have COVID-19 has impacted many countries, and what it did to economy is very stressful. So, firstly, we'll convert it into words, tokens, as you say, and then after applying uh, the necessary block to the stop words, we'll finally derive in with COVID-19 pandemic impacted many countries, economy stressful, right? So then we move on to lemmatization. Lemmatization is actually breaking down uh, prefixes and suffixes of a word into its most simplistic meaning, uh, simplistic word having at least some semantic meaning in it. So this is actually an absurd sentence to consider. I know, but upon lemmatizing this particular sentence, we'll derive with. You can see the changes. Language, the S is removed. Mice is converted to mouse. Cities is converted to a singular city. All right. So yeah, it actually breaks down a complicated word into simple word, into its simplistic word. All right. So the prerequisites are almost over, and we will club them all together now to build the whole machine learning algorithm. So first we'll import the necessary libraries, as you can see, and the files in it and the data set. The data set is named news.csv. It's in comma separated value format, and it actually has it's actually placed in this particular order. And the only columns of interest of our interest is this label, text, and the ID, of course. Mm, the label actually tells us whether this particular that particular text or the news is fake or real. All right, since it's already a trained actually it's already predefined data set. So we already know that whether the news is fake or not. But with the help of this particular data set, we can build a model which will train and then will test with this data set, and we can uh, you know apply it to other data sets that are not defined priorly. So first, in this particular data set, we'll process its text, and remove the stop words, the punctuations, the conjunctions, etc. Then we'll lematize it, as we all know what it is, and tokenize it. All right. So here we have created an object for lemmatizing, and we have created an empty list where we'll finally get the text that we want, that we would like to refine later on. And we'll first iterate it in the range of um, the whole data set, the whole ID that we have. All right. So we'll first remove the non-letters and replace them with spaces, and then we'll lower each and every text in the data set, because that would kill the ambiguity we might encounter later on, which actually is a huge problem, as we are dealing with a computer and not a human being. All right. So yeah, after doing that, we'll lematize it, we'll break down complicated words and also ignore the words uh, that are included in the stop words for the English language, and then append the lemmatized words in this empty list. And as you can see, say the seventh news, the news in this data set having the ID 7, uh, it's actually broken down to its most simplistic meaning, having semantic references. Then we'll apply TF-IDF vectorizer. This actually helps in extracting features from each and every word that is present in the sentence. So we'll only encounter with the features having the top 5,000 features in the in this data set. All right, and then we'll divide the data set into two parts: training and testing. So here you can see we have taken the test data set size as 33% of the whole data set, and the rest is what we will train. All right, and these are actually the first 20 features of the data set that we are going to encounter. Then we have displayed the same in a vectorized format. So this vectorized format helps us in knowing the weightage of each and every feature of that particular um, news. So there might be, of course, not everything is zero. There are tons and tons of words. As you can see here, there are 5,000 columns in each and every, um, you know, to each and every row in this vectorized format. Here you can see 5,000 columns. So yeah, that will display the the weightage of each and every feature in that particular news. Yeah, and then after doing this, we'll use something called as multinomial naive Bayes theorem. I'm sorry if I spelled it wrong. So this will actually help us in knowing the output of a particular news, since our target attribute here is label. All right, label is our targeted attribute, as this is our dependent output. All right, so it is dependent on the features that we have extracted from these texts via TF-IDF vectorizer. All right, so these are the features. So since Bayes theorem is in the format of uh, a dependent output over an with an independent input. So for each and every feature, say we'll find out the probability of a label for, say, this particular news of ID1. All right. So we'll find out each and every probability of the label for ID1 given feature one. Feature one is abandoned, so to say. And then we'll move on to abandoned, and then we'll take out the feature. We'll take out the probability of label with respect to this. So that is actually a relative probability that we are taking out. So if we marginalize it all, we'll finally find out the the fake whether the news that particular news is fake or real. So say fake is the probability of fakeness of the news with respect to all the given inputs is 0 0.6, and the vice versa would be for real, right? So since the probability of fakeness is more than the probability of real of that particular news to be real, so that news would be a fake one. All right. So after training 67% 67% of the data set, we'll find the accuracy score by implementing the model that we have built with the testing set. All right. So by that we have found out our accuracy to be 87.6%. I guess that's a pretty good score, to be frank. Yeah, thank you.